Here in Washington, we have our own volcano threat in the Cascade Mountains, which on average erupts once or twice every century.
Less than 70 miles from Seattle is Mount Rainier, so that if a big eruption were to occur, it's likely.
Mount Rainier looms over the Pacific Northwest as both a natural wonder and a geological enigma. And when the USGS issues a red alert, it is not a trivial matter. Recently, satellites monitoring volcanic activity detected an unusual and deeply concerning movement of magma beneath the volcano's surface, prompting authorities to elevate the threat level. The shift in magma dynamics beneath Rainier signals an escalation that volcanologists and emergency planners have feared for decades. This isn't merely a geological curiosity, it is a direct indication that the processes fueling the stratovolcano are entering a volatile phase that could alter the landscape, the region's safety, and the perception of stability in one of the most heavily populated volcanic hazard zones in the United States. Before we start, smash the like and subscribe buttons for more updates. The red alert issued by the USGS is the highest possible warning in their system. It signifies that not only has magma been detected moving beneath the surface, but the level of unrest is significant enough to warrant heightened monitoring and preparation. What makes this alarming is Rainier's geological history. Known for its immense size and vast glacial coverage, it has long been considered one of the most dangerous volcanoes in the country. Its slopes are laden with unstable rock and ice, which, when disturbed by volcanic activity, could generate catastrophic lahars, raging mudflows that can thunder down river valleys for miles, swallowing entire communities in their path. The magma detected by satellites hints at a reawakening of these destructive forces, creating a scenario where natural beauty becomes a looming threat. Satellite imaging has revolutionized the way we track volcanic systems. The ability to detect subtle bulges in the Earth's crust, shifts in thermal emissions, and the gaseous plumes that escape from cracks near volcanic peaks gives scientists unprecedented insight into subterranean processes. At Rainier, these tools have revealed patterns that are anything but ordinary. The magma movement appears to be both rapid and voluminous, suggesting that it is not a minor intrusion but rather a significant push of molten rock forcing its way upward. This development has led scientists to believe that pressure within the volcano's chambers is rising faster than anticipated, raising the likelihood of surface instability. The geography surrounding Mount Rainier amplifies the potential consequences. Sitting just southeast of Seattle and Tacoma, the volcano is in close proximity to millions of residents. Unlike remote volcanic systems that can unleash their fury with minimal impact on human life, Rainier's awakening carries implications for metropolitan centers, economic lifelines, and critical infrastructure. The rivers that cascade down its flanks, the Puyallup, Nisqually, Carbon, and White, are conduits that could channel volcanic debris flows directly into populated areas. With magma surging below, every inch of surrounding terrain becomes vulnerable to rapid transformation. What makes this moment even more striking is the psychological weight of Rainier. To those who live in its shadow, it is a permanent fixture on the horizon, a snow-capped sentinel that defines the landscape. Yet beneath that tranquil appearance lies one of the most volatile geological structures in North America. The red alert strips away the illusion of timeless serenity and replaces it with the stark reminder that volcanoes are dynamic, living systems that can shift from quiet to catastrophic with little warning. The detection of magma movement is, therefore, not just a scientific data point, but a revelation that the ground beneath is restless and unpredictable. Volcanologists who study Rainier emphasize that magma movement does not guarantee an eruption, but it undeniably raises the probability. The mere act of magma forcing itself into new pathways destabilizes rock formations, heats groundwater, and fractures existing structures within the volcano. Each of these effects increases the potential for explosive activity or for sudden collapses of glacial ice. In the worst-case scenario, magma could reach the surface explosively, venting ash high into the atmosphere and generating pyroclastic flows that incinerate everything in their path. Even without an eruption, the disruption alone could set off massive lahars, a phenomenon Rainier is particularly infamous for. The USGS Red Alert, therefore, is not just about predicting fire and ash, but about anticipating cascading hazards. Lahars, in many respects, are the most terrifying possibility. Historical records and geological deposits reveal that Rainier has unleashed these torrents before, burying landscapes dozens of miles away. A lahar triggered by magma-heated ice could surge down river valleys within minutes, moving faster than cars on a highway, carrying boulders, trees, and entire structures. The movement of magma beneath Rainier is like a match held to a powder keg of unstable ice and rock, waiting for the smallest spark to detonate the system. Beyond the immediate geological risks, the red alert forces communities to grapple with preparedness. The Pacific Northwest is no stranger to natural hazards, but volcanic eruptions require a unique set of responses. Evacuation routes must be clear, emergency shelters must be ready, and communication systems must be tested. The challenge is that the potential scope of impact from Rainier dwarfs most regional disaster scenarios. Unlike earthquakes or storms, volcanic hazards can unfold in multiple forms simultaneously: ashfall, mudflows, lava, and toxic gases, demanding a comprehensive, multi-layered response. The magma movement beneath Rainier is a reminder that preparedness is not optional, but essential for survival. The detection also underscores the interconnectedness of science and policy. Satellites, seismic instruments, and GPS sensors provide the data, but translating that into action requires coordination across federal, state, and local governments. The red alert at Rainier compels leaders to balance transparency with caution, ensuring that citizens are informed without being overwhelmed by panic. It is a delicate line to walk, especially given the economic and psychological stakes. Businesses, schools, and households all look to officials for guidance, and the knowledge that magma is on the move beneath their beloved mountain weighs heavily on every decision. There is also the environmental dimension. Rainier is not just a volcano, it is a national park, a habitat for countless species, and a water source for communities. The movement of magma beneath its glaciers threatens ecosystems that have thrived in delicate balance for centuries. Ashfall could poison rivers and lakes, while lahars could obliterate forests and meadows. The red alert is not merely about human survival, but about the preservation of entire ecological networks that depend on the stability of the mountain. From a geological perspective, the magma detected beneath Rainier is part of a much larger narrative of plate tectonics and subduction zones. The Cascades, of which Rainier is a part, are the surface expression of immense forces where the Juan de Fuca plate dives beneath the North American plate. This process has built mountains, shaped landscapes, and fueled eruptions for millennia. Rainier's current restlessness is another chapter in that ongoing story, one that highlights the dynamic nature of Earth itself. To scientists, the magma movement is data that fits into a broader model of tectonic behavior. But to the people of Washington, it is a potential crisis unfolding beneath their feet. The terrifying aspect of magma movement lies in its invisibility. Unlike storms that can be seen on the horizon, or earthquakes that strike without warning, magma builds quietly beneath the surface, its progress revealed only through the most advanced tools. The fact that satellites have detected it is both reassuring and unsettling. Reassuring because the monitoring system works. Unsettling because it reveals that forces are already in motion. The red alert transforms invisible danger into visible urgency, compelling people to acknowledge that what lies beneath Rainier is no longer dormant. The cultural significance of Rainier also deepens the impact of the red alert. For indigenous peoples of the region, the mountain has long been a sacred presence, woven into stories, traditions, and identity. The knowledge that it harbors restless magma beneath its peaks resonates not only as a scientific warning, but as a profound shift in the spirit of the land. For modern residents, Rainier represents home, stability, and beauty. The disruption of that stability cuts deep, forcing communities to confront the fragility of the environment they treasure. As magma continues to push upward, the focus sharpens on time. How quickly will it move? Will it stall beneath the surface or breach it in a violent eruption? These questions drive the work of scientists who analyze seismic tremors, gas emissions, and ground deformation. Every new piece of data adds urgency to the story, yet the uncertainty lingers. The red alert acknowledges that while the precise outcome is unknown, the level of risk is undeniable. That uncertainty itself is part of the danger, because it forces people to live in a state of heightened vigilance without clear answers. The red alert at Mount Rainier is not a fleeting headline, but a defining moment for the Pacific Northwest. It marks a shift from viewing the volcano as a distant possibility to confronting it as an immediate threat. The magma detected beneath the surface is a signal from the Earth itself, a warning that the forces that built the mountain are stirring once again. For scientists, it is an opportunity to study volcanic processes in real time. For emergency planners, it is a call to action. And for residents, it is a reminder that life in the shadow of a volcano comes with both breathtaking beauty and existential risk. The scale of Rainier's potential impact sets it apart from many other volcanoes. Its glaciers alone, when destabilized, can unleash volumes of water and debris unmatched elsewhere. Combined with magma-driven forces, the potential outcomes are vast and devastating. The red alert serves as a beacon, telling everyone in the region that the stakes have risen, that vigilance must sharpen, and that the rhythms of the Earth are shifting in ways that cannot be ignored. The USGS has sounded the alarm, and satellites have revealed the magma's restless movement. The mountain that stands as a symbol of strength is now a symbol of fragility as well. Beneath its icy crown, heat and pressure are building, a reminder that the ground beneath is alive, and that humanity remains at the mercy of forces far older and more powerful than civilization itself. The red alert is not the end of the story, but the beginning of a tense chapter where every tremor, every plume, and every shift matters. Rainier is stirring, and the world is watching. The declaration of a red alert at Mount Rainier following the satellite detection of magma movement has placed the Pacific Northwest at the center of a global spotlight. The world has always regarded Rainier as one of the most iconic mountains in North America, a towering sentinel cloaked in glaciers and framed by endless forests. Now, however, the mountain is being scrutinized for reasons far more serious. The relentless watch of satellites has uncovered signs of molten rock surging upward, destabilizing assumptions about Rainier's dormancy and shifting the narrative from admiration to vigilance. This phase of magma unrest introduces new dimensions to the scientific, social, and environmental story of the region, dimensions that have not yet been fully appreciated. One of the most striking aspects of this development is the sheer scale of the systems involved. Mount Rainier is not an isolated mountain in the middle of nowhere. It is part of the broader Cascade volcanic arc, a chain of formidable peaks born from tectonic processes that span the Pacific Ocean. The satellite data showing magma movement beneath Rainier is not just an isolated finding about a single volcano. It hints at larger tectonic dynamics playing out along the subduction zone. The grinding of the Juan de Fuca plate beneath the North American plate is the grand engine of this volcanic system, and Rainier's restlessness could suggest that energy is being redistributed along the arc. Scientists are now carefully watching not only Rainier but also its neighboring volcanoes, from Mount Adams to Mount St. Helens, in case this new pulse of magma indicates broader shifts in the region's geologic equilibrium. At the human level, this red alert has awakened discussions about infrastructure resilience. The communities in the lowlands below Rainier are heavily interconnected with transportation systems, highways, rail lines, and airports that serve as lifelines for commerce across the Pacific Northwest. An influx of magma under Rainier introduces risks that extend far beyond the slopes of the volcano itself. Ash plumes, if vented skyward, could choke flight corridors across the west coast, grounding aircraft and disrupting global travel. A single major eruption in the Cascades could ripple outward, delaying cargo shipments, halting passenger travel, and introducing widespread economic shock. Even the simple knowledge of magma on the move forces airlines, shipping companies, and government planners to reconsider their contingencies for operations in a region where the skies are frequently trafficked. Schools and hospitals, too, must recalibrate their understanding of hazard preparedness. It is not enough to have earthquake drills or plans for seasonal storms. The red alert requires that institutions consider layered, complex disasters that may unfold in unpredictable ways. Ashfall, for example, can infiltrate air filtration systems, clog machinery, and render hospitals difficult to operate just when they are needed most. Lahars racing downriver valleys could strand communities, cutting off access to emergency care and supplies. The magma beneath Rainier, therefore, is not only a geological reality, but a pressing societal challenge. compelling leaders to weave volcanic hazards into every aspect of public safety planning. Beyond immediate practicalities, there is the profound question of how societies psychologically absorb such warnings. A red alert changes the way people look at the world around them. Where once Rainier was a majestic backdrop to daily life, it now feels like an unpredictable neighbor whose moods must be carefully monitored. For families, this means explaining to children why the mountain on the horizon, often drawn in classrooms or used as a symbol of home, has suddenly become a potential source of disruption. For business owners, it means weighing the risks of investing further in communities that lie squarely in the paths of historic lahars. For local governments, it means walking a careful line between honesty and reassurance, giving people the tools to prepare without fostering paralyzing fear. The red alert also pushes scientific innovation into overdrive. With magma detected moving beneath Rainier, researchers are rushing to deploy new instruments and refine their models. Drones, advanced seismic arrays, and improved satellite imaging techniques are being used to capture every subtle shift in the volcano's behavior. Each new dataset adds depth to the picture of what is occurring miles beneath the surface. For volcanologists, Rainier's awakening provides a real-time laboratory to test theories about magma dynamics, crustal responses, and the interplay of ice with molten rock. The lessons drawn here may one day be applied to other volcanic systems around the globe, making Rainier not just a regional hazard, but a focal point for global scientific advancement. From the perspective of natural history, the magma movement at Rainier is a continuation of cycles that have shaped the Earth for millions of years. The glaciers on its slopes, the rivers that flow from its base, and the forests that surround it all exist because of the interplay between volcanic fire and the relentless sculpting of ice. The red alert is a reminder that the forces that built these landscapes are still active, still capable of profound change. For those attuned to the rhythms of geology, the magma movement is not an aberration but a return to form, an expression of the Earth's continuous transformation. Humanity's challenge lies in learning how to coexist with that transformation without being overwhelmed by it. Interestingly, the cultural ramifications extend well beyond the region itself. Rainier has long been a symbol used in art, literature, and even branding. Images of the mountain adorn everything from company logos to tourism brochures, promoting the Pacific Northwest as a land of beauty and stability. The news of magma unrest challenges that narrative, raising questions about whether people's relationship with Rainier will shift as they confront its volatility. Can a mountain still symbolize permanence when satellites reveal it to be restless? Can it remain a point of pride when it becomes a source of anxiety? The red alert does not just alter scientific understanding, it alters the cultural imagination of what Rainier means. There is also a deeper philosophical implication in the satellite detection itself. Humanity has reached a point where technology can peer beneath the surface of mountains, unraveling secrets that would once have gone unnoticed until eruption. This capacity for foresight is remarkable, but it also introduces new responsibilities. With the ability to detect magma movement comes the obligation to act on that knowledge, to prepare communities, and to communicate risks with clarity. The red alert at Rainier is thus not only a geological event, but a moral test of how societies use the tools of science to safeguard lives. While much attention is placed on the potential for catastrophe, the detection of magma also illuminates the resilience of human systems. The very existence of monitoring networks, the readiness of emergency planners, and the ability of communities to mobilize are all signs that societies can adapt to living in proximity to volcanoes. The red alert is frightening, but it is also a demonstration that humanity is not powerless. By anticipating risks and preparing responses, people can mitigate the impacts of even the most formidable geological events. Rainier may stir, but human ingenuity and organization can shape how its restlessness affects lives. The ongoing situation also sheds light on the interconnectedness of global hazards. Volcanic activity in one region can have repercussions that extend far beyond its immediate vicinity. Ash clouds can disrupt international travel, global supply chains can be interrupted, and climate systems can be subtly influenced by the injection of volcanic gases into the atmosphere. The magma detected beneath Rainier therefore has implications that stretch across borders. Other nations are watching closely, not only out of solidarity with the Pacific Northwest, but because they recognize that their own fates are tied in part to the behavior of volcanoes thousands of miles away. At the same time, the red alert underscores the limits of prediction. Scientists can measure magma movement, monitor seismic activity, and assess gas emissions, but they cannot say with absolute certainty what Rainier will do next. This inherent uncertainty is one of the most challenging aspects of volcanic hazards. Unlike hurricanes that can be tracked with cones of probability, volcanoes can switch between dormancy and eruption with startling abruptness. The magma beneath Rainier may stall, cool, and solidify, or it may find a pathway to the surface. The inability to predict the precise outcome is frustrating, but it also reflects the complexity of the Earth's inner workings. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Mount Rainier's magma movement? Eruptions soon or false alarm? We want to hear from you. Thank you for watching, and see you next time.